Hello. In this video, we want to talk about contravariants, covariants, and mixed tensors. In these previous videos, we've discussed contravariants, covariants, tensors, but we didn't discuss anything under mixed tensors. This time around now, we're going to talk about mixed tensors, but then we still want to relate contravariant and covariant vectors to mixed tensor. So please let us be attentive. Now, if n squared quantities, A, Q, S, this is obviously talking about contravariant tensor, in a coordinate system, let's say the coordinate system is x1, x2, or superscript, okay, are related to n squared. This time around, not n quantity alone, other quantities, unlike in the previous examples. That one is what? A bar BR is still what? Is still superscripted in another coordinate system, another coordinate system, x bar 1, x bar 2, and so on, x bar n, okay, by the transformation equation. Now let's look at how this transformation equation will be written. How this one will be written. Now, first of all, note that we have n squared. 2. You observe that we have rank 2. The indices are 2. So rank 2. So we shouldn't be surprised that this is a different explanation to what we have discussed before, rank 2. Remember those previous ones we talked about rank 1. So now we start with this. Because we are from here, we start with this. We have what? The A bar BR can be, you can use, summation to the indexes. So since this is PR and we are moving to AQ, so AQ will be the last thing here. AQ, okay. Now you can say S is from 1 to N. You can say Q is from 1 to N. That is Q has here. Okay. Now we have what? We have del X, with respect to that is X bar P all over, it will now be what? Q. Del S Q, beautiful. Then del X bar R all over S now. Del S S. Yes. So this is the representation. You can see the way I've just done mine. So don't forget, we have defined X to be 1 to N, Q to be 1 to N. So this is perfect. This is perfect. This is that. This is it. So you can write P R is 1, 2 to N. So you have P R. You already know that. So instead of that, you can write or. Instead of including this summation sign, you can just write this. You can just write this. Take note of how those indices are written so that you not run into trouble. You observe that they are written consecutively. When I pick P, I pick Q. When I pick R, it's bar. When I pick R, I pick S as the one under it. So that is by adopted. This is by the adopted. They are called what? By the adopted convention. That's the convention we adopted. Convention. That's we can write this. Write this instead of this. Okay. These are called. What do we call it? These are called contravariant tensors. Now, because these indices are up, contravariant tensors or vectors of the second rank or second order. Yes, because we have to, okay, and say contravariant vectors as component of contravariant vectors of second order or second rank or rank 2. Or we can say these are components. These are components of contravariant tensors of rank 2. Of rank 2. You can say of rank 2 or second rank, each other one. Now, to define the second one, which will be the other one, which is covariant, let's try to save our time. Let's try to save our time and make some adjustments to the definition so that we won't waste much time defining. So AQS now. Okay, AQS now. Okay, and added to other quantities, and this one is going to be this. This one is going to be this. Yes. So let's assume the quantity remains, the coordinate systems remain unchanged. I think. Are we done there? Yes. Yes. So now, and our PR now, PR will be down, sorry. Okay, so we just make some changes. QS will be down. Yes. I hope you are getting it. This one will come up, so this one will come down. But P, this is Q. Yes. Why? Because we are talking about covariance, where the indexes will be down, and you can see from what you are given, the indexes are down. Okay, this one will be bar R. This will be S. Yes. So you can change this one as well. I have this A bar PR. So this one will come up. This one will be bar P. This one will come up S bar R. And this one will be QS down. So that is it. So now say these are components of covariance, no longer contravariant. Covariant tensor. Covariant tensor of order or rank 2. These are components of I hope you understood this. Okay? Just try to go put them side by side, try to understand the changes, and you see that it's very easy to understand. Now let's look at the mixed tensors. When we have mixed tensors, now when we have mixed tensors, I didn't want to claim okay. We can write this. We can write this for mixed tensors. Write this. Actually, what we need is to understand how they can be written, how their transformation equations are written. That's what's important. That's what is important. The note is given to you for you to understand, for you to fall back on something substantial, so that when you are studying it, you don't have any issue. You will be able to understand everything in details. You can go back to the notes several times to understand it fully. Now, similarly, the N2 quantities now, we are using not 2 ranks. A, Q, S. You will see something here. Are called components of a mixed tensor. Of the second rank, if let's look at this, A bar PR, you can see, is equals to partial derivative of ds bar d bar s bar p ds cube dss all over ds bar r a q s. Is easy, very easy. Yes. How? Remember the a bar pr was ds bar p all over ds. We have that was the p qr q ds bar r all over ds s. Now that is the for the contravariant. Okay. Now here we have been given that this is the first quantity. Then the second one is what we are. You understand now? We are transforming to the second one now. So that's why you have a q s here. We call it a mixed tensor because we have index as superscript and index as subscript. We have a combination of what? Contravariant and covariant tensor. So we call it mixed tensor. And so in that case, you have to be careful here. If you want to transform, it will be start with this now because it's contravariant over what follows? Contravariant again. Okay. Then you know what? Anytime we are dealing with covariant, it will be upside down. Good. So the bar will come down, the s will come up. Just juxtapose. Compare with this. You can see that it is r over s, but here it will be s over r, which aligns with, which agree with the way we discussed the previous covariant tensor. So this is about that. Now let's look at tensors of rank greater than 2. We can have tensors that have ranks that are more than 2. We can equally have tensors whose ranks are more than 2. Yes. We have no more by rank now. You know, this one that we have, this mixed tensor is of rank 2. Yes. Because it has one superscript and one subscript. So tensors of rank greater than 2. Tensors of rank greater than 2. This is a subtopic for this. Let's look at them. Let's look at this. A, Q, S, T, R, L are components, it's a very good example of a mixed tensor, of course, of rank 5. Yes. Contravariant of order 3. And covariant, you can use order for rank. You say, okay, covariant of order 2 if they transform according to the relations. Let's look at how the own transformation will look like. Let's look at it. You know this. Now we have a second one, PRMIJ. So if we don't want to use a summation convention, so to what? Dx prime P all over, you know, the other one is Q, ds Q, beautiful, ds prime R all over ds S, yes, ds prime M all over dst. Don't forget our target is we are multiplying by a q s t r l. Now using this now, remember this one will still come down, but the other one, so now d x r all over dx bar I dxl all over dx bar j. So multiply by a q s t r l. So that is the transformation. That is the transformation. So that's it's very simple. Just follow the way I've done mine. You see that it's not difficult. Follow the way I've done mine. This x will not s. This is slip of hand. This s. So this t. Okay, that's it. This l. This I. Okay, so it's different from j. Don't get it twisted. So that's that about that. So with this, we have come to the end of contravariants, covariants, and mixed tensors. So do well to click on the notification bell so that each time I upload a video, you'll be daily notified. And don't forget to watch, to always share and like my video. See you in subsequent videos, still on Introduction to Tensors Analysis with examples. God bless you.